Aging is not a uniform process. The rate at which it unfolds and the symptoms it produces differs markedly between individuals. Some people retain energy, cognitive clarity, and physical function well into their 70s, while others struggle with fatigue, inflammation, and chronic illness decades earlier. Emerging research in personalized nutrition helps explain why. Each person's metabolism, insulin sensitivity, microbiome composition, and micronutrient status uniquely shapes how their body responds to food and how efficiently it engages in self-renewing processes like autophagy. As a result, the most effective anti-aging nutritional strategy is not one size fits all, but one that calibrates carbohydrate intake and micronutrient levels to individual physiology. Carbohydrate tolerance is one of the most variable features of metabolic health. Some individuals, particularly younger, active, insulin-sensitive people, can consume moderate to high amounts of carbohydrates without significant blood sugar spikes or oxidative stress. Others, often those with insulin resistance, metabolic syndrome, or genetic predispositions, experience excessive insulin responses, inflammation, and accelerated aging even from moderate carb loads. For the latter group, high-carbohydrate diets suppress autophagy, promote fat accumulation, and amplify the wear and tear that leads to age-related decline. A personalized approach involves determining where someone sits on this metabolic spectrum and adjusting carbohydrate intake accordingly, not necessarily to a universally low level, but to a range that maintains stable insulin, supports metabolic flexibility, and allows autophagic repair to occur regularly. Tools like continuous glucose monitors, CGMs, fasting insulin tests, home IR calculations, and postprandial glucose tracking offer a clearer picture of individual carbohydrate tolerance. These metrics can reveal if a person's body is effectively processing starches and sugars or struggling to keep blood sugar in check after meals. The results often suggest adjustments that go beyond simply lowering total carbohydrate intake, for example, timing carbs earlier in the day, combining them with fiber or fat to blunt glucose spikes, or focusing exclusively on low glycemic sources like legumes, leafy greens, and resistant starches. These strategies help reduce autophagy-suppressing insulin elevations while still supporting energy needs and dietary diversity. Micronutrient needs are equally personal, especially when it comes to supporting autophagy and slowing aging. Genetics, digestive health, medication use, age, and lifestyle all affect how well someone absorbs and utilizes essential vitamins and minerals. Older adults, for example, often have reduced stomach acid and intrinsic factor, impairing absorption of B12, magnesium, and zinc. Certain medications, such as metformin, proton pump inhibitors, and diuretics, further deplete B vitamins and electrolytes. Others may carry genetic variants, like MTHFR or SLC23A1, that reduce the conversion or cellular uptake of key nutrients, increasing their need for specific forms or higher doses. Even within healthy populations, nutrient status varies widely, and these small imbalances can make or break the cell's ability to activate repair processes like autophagy or mitochondrial renewal. Personalized anti-aging protocols take these factors into account by testing vitamin and mineral levels regularly, not just for overt deficiency, but for optimal ranges. Functional lab ranges for vitamins like B2, riboflavin, B3, niacin/NAD, B6, D, and K2 are more narrow than standard medical cutoffs. A normal level on a basic panel might not be enough to support maximal cellular function in an aging body. The goal is not to avoid disease, but to optimize performance. For example, vitamin D levels of 30 nanograms per milliliter may prevent rickets, but levels closer to 50 to 70 nanograms per milliliter are more strongly associated with reduced inflammation, enhanced immune surveillance, and autophagy-related gene activation. Similarly, B vitamin levels that barely meet daily minimums may still result in sluggish mitochondrial turnover and impaired metabolic signaling over time. The ideal personalized protocol begins with a comprehensive metabolic and nutritional assessment. This includes fasting glucose, insulin, HbA1c, lipid profile, inflammatory markers, and detailed micronutrient testing, ideally including intracellular levels or functional markers. It may also include genetic screening for nutrient transport and metabolism variants. From there, dietary interventions can be tailored precisely, carbohydrate levels set to match insulin sensitivity, vitamin intake adjusted to correct borderline inefficiencies, meal timing aligned with circadian rhythms, and fasting windows to enhance autophagy. Supplementation may be targeted, not generalized, using methylated B vitamins, bioavailable magnesium, or lipid-soluble K2 forms when needed, rather than blanket multivitamin strategies. Importantly, personalized anti-aging nutrition isn't rigid. It's responsive. A person who becomes more metabolically flexible through improved insulin sensitivity may be able to reintroduce certain whole food carbohydrates without blunting autophagy. Someone who corrects a long-standing vitamin D deficiency may see reduced systemic inflammation and improved energy metabolism within weeks. As the body adapts, so should the protocol, continuously evolving with lifestyle, seasons, age, and biofeedback. In essence, the path to slowing aging lies not in extremes, but in precision. The synergy between carbohydrate management and vitamin optimization only reaches its full potential when it reflects the individual's own metabolic blueprint. Personalized nutrition offers a science-backed route to achieving that balance, one that supports cellular repair, minimizes chronic stress, and helps the body retain its resilience well into later life. By listening more closely to the body's subtle cues and tailoring interventions accordingly, we move closer to a future where age is no longer defined by decline, but by sustained vitality.